a plane is facing due west and is attempting to fly at 120 kilometers an hour. However, the air is moving south at 40 kilometers an hour. And the wind is blowing or something. I would like you to tell me how fast is the plane going relative to the ground, and what direction is the plane actually moving relative to the ground. I was nice enough to draw you a picture. Okay? Does everybody understand what I'm asking them to complete? I want to know the speed of the plane and the direction of the plane. You may use whatever reference system you wish. First, there's a couple of you who did this, and let me just say for the record, can we agree the plane's probably going this way? So any attempt to do, say, this would be wrong, right? Because the plane's not going that way. Or, not that. This would also be wrong. All right, so, step one was to establish your directions. And wouldn't you agree that south and west are probably reasonable things to do? So, second step was to create a triangle that you could use to find your answer, and I think our possibilities here would be, that would be a possibility, correct? And clearly that would be a possibility. Doesn't really matter which one of these we choose, it's the same. So this one's already there, I'll make that my possibility. I'm gonna take just a moment to draw in, though, my cardinal directions, just for reference. All right, my reference now for west and south, and draw in my resultant vector, so I have a full triangle. Just step 2, identify a triangle. Step 3, identify the angle that you're going to work with. I'm going to work with this angle. Call it theta. I'm going to label my sides opposite, adjacent, hypotenuse, all from there. Now, I'm not going to do the full thing. The next step, write out your trig functions. Look, I can look at this and realize which trig function I need, right? I just need tangent. I could write them all out, but I have the opposite and the adjacent side. So based on that, I'll make sure my calculator's in degrees. I'll write out the one function that I need. Recognize that I'm on the type where I have two sides, and then choose the inverse tangent function. To find that my angle is 72 degrees. Right? Now, I could continue to use trig to find the hypotenuse. I would just need to pick a different ratio of sides. So I could say, well, sine of 72 has to be 120 over h. And this will help me figure out that h is 126 kilometers an hour. But I could check my work or find that differently by doing Pythagorean theorem, which is probably easier. But here's where, although a lot of you have these numbers, you don't have the right answer. It is true that this is the speed of the plane relative to the ground. But it's 72 degrees as measured from here, facing south, turning towards the west. If you said south of west, you're wrong. For south of west, I would need 18 degrees south of west. Right? You understand that it's wrong if you put this angle as west of south? It'd be okay if you put it south of west like I have, but you still have to base it on your reference. And just looking at your picture should have told you that. It's a big angle, right? 72 degrees. So I think some of you still have problems with this. But for the most part, this is better than what I saw in third period for sure. So can I show you what we actually have to do with this instead of this? Because this is, even what we're gonna have to do with it is particularly exciting, but at least it's not that. So I'm supposed to be teaching you how to add vectors together. And adding vectors together is not particularly complicated, but if you can't do this part, you won't be able to add vectors together. So there's many ways to do this. I'm gonna teach you a way. And there's just three things you have to do. First, you have to convert everything to rectangular. That's got to be first. We can only do one-dimensional problems, so we need to break our problems up into Cartesian coordinates. And we have to use the same set of Cartesian coordinates for all the vectors. The second thing we have to do is add like components together. That's the second thing we have to do. The last thing we have to do is convert our answer back to polar. Use the word resultant. Because the result of adding vectors together is called the resultant. These are the three steps. And I'm saying it because that's all you have to do, but that can be, it depends on how many vectors you have. If you're adding together 12 displacement vectors, then you have to convert 12 vectors to rectangular coordinates first, and then add up all their components, and then convert your result back to a polar answer. Generally, we do mostly these two for most of the year when we deal with forces and stuff. We don't always express our answer as a resultant. The plane is 120 kilometers an hour, 20 degrees west of south. But the breeze, which is the blue arrow, is what's actually pushing down on the plane too. It's adding to the plane's velocity, which means that the plane actually has a velocity that looks something like that. Right? If we add the plane's velocity with the wind's velocity, it's something like that. So the result is going to be something that looks like that. The plane's going to be more towards the south than it would expect to be because the air is moving. You guys follow what's happening here? Now, the truth is, we want to find the yellow arrow that represents the resultant velocity of the plane. But to do so, we need to add together like components. We need to convert everything into rectangular. So, we'll work one portion of the problem at a time. We'll start with the plane. I'm going to label this way south. Is that okay with you? Can I make south the positive direction? Does it make any difference to you guys? Is that all right? I'm going to label this the west. I'm going to make the west the positive direction as well. Is that okay? Remember, I'm going to need to add vectors together, so what I'm trying to do here is to give myself reference points, reference information. I need to decide on a triangle that can describe this plane so I can break up its velocity into a north-south component and an east-west component. Does that make sense? So I'm going to choose a triangle. I'm not going to make it too tough. I think the best one I've got is this one. Is that a good one to use? Is that okay? I could use the other one, but I know that this is 20 degrees. So 120 kilometers an hour, 20 degrees. I need to find the the part of the plane speed that's in the north-south direction and the part of the plane speed that's in the east-west direction. In fact, there's going to be a north-south portion of this and an east-west portion of this. I could just as easily say this is the y part and this is the x part if you'd like, because that's kind of what we're doing. So don't stand on ceremony here. This is still just an x and y axis. But I'm going to write off to the side here that this is the plane. I'm going to make a grid. I'm going to say the plane's velocity is going to have a north-south part and an east-west part. And then in a minute, I'm going to do the wind, which is going to have a north-south part and an east-west part as well. And then when we're done, we will add the components together. I'm making a chart to keep track of my information. You guys all okay with that? Let's work the problem with the plane then. First, I see that I have an angle and a side. I have an established triangle. This is my opposite side. This is my adjacent side. This is my hypotenuse. I want to be very fast at this, but I understand that some of you are still having to take your time, so I'm taking my time. Using that little fork in the road, I'm going to say, okay, sine 20 degrees equals opposite over 120. Looks like I can figure out the opposite side. And cosine 20 degrees is going to equal adjacent over 120. I don't need the tangent. All right, this will be good enough. This will give me my two sides. So again, we're not solving triangles. We're using this to solve a problem. So the opposite side appears to be 41 kilometers an hour. The adjacent side appears to be 112.7 kilometers an hour. Are we in agreement? Am I going too fast? So it's all okay? All right. Both of these are positive based on the way I chose positive and negative. So I'm going to go to my chart. The north-south speed of the plane is 112.7 kilometers an hour. The east-west speed of the plane is 41 kilometers per hour, and they are both positive. Is that okay? All right. Let's consider the wind. Notice I'm going to consider it separately. I'm going to just keep it by itself. However, I gave you something easy for the wind. The thing is, I need to make sure I am being consistent. Right? So this has to be the positive direction, this has to be the positive direction. The wind was 40 kilometers an hour due south. I don't have to break this up, do I? There is no east-west component, there is only a north-south component. So my east-west component will be 0, and my north-south component will be 40 kilometers an hour. Are we all good? Now, you can, and some people will, turn these into like mathematical sentences by putting unit vector values after these and add them together and write plane's velocity as 112.7 y hat plus 41 x hat. That way you can only add the y things together and the x things together. I think just keeping a little chart here is okay. There's lots of different ways to do this. Anybody ever used e to the I theta notation for stuff like this? All right. Anybody use I hat, j hat, k hat notation? Okay. Got one. And I think that's probably it. If I only have one person who knows that one, then we're probably good. Add down, right? I'm just going to add these things together. Plane plus the wind. Step 2, add like components together. These are like components. They're in one dimension. These are like components. They're in one dimension. So 112.7 plus 40 is 152.7 kilometers an hour. And this is in the north-south direction. And then 41 kilometers per hour. That's in the east-west direction. Any questions about that? This is the result. And technically, I'd probably put this is y hat plus x hat. Something to indicate that these are in different directions. So, convert our answer. I have to go 152.7 downwards. I can do that. And 41 to the positive x, or to the west. So 152.7, 41. This is still south, this is still west. We keep the same consistent coordinate system for the whole problem. So whatever you set as positive stays positive, whatever you set as negative stays negative. And we now need to figure out the angle, and we need to figure out the speed. We just did this a few moments ago, so I know that you can do this. It looks to me like this is the opposite side, this is the adjacent side, this is the hypotenuse. I'm thinking tangent again. So tangent of theta is 41 divided by 152.7. I get that theta is 15 degrees. I get 158 for my plane speed. Not done until we frame it correctly. 158 kilometers per hour at an angle of 15 degrees west of south. Start from the south, turn towards the west, 15 degrees. Sum of vectors. This is the easy one. This is the easy part. They are harder. So, you've seen, so again, the river's going straight up as we see it in the picture. I have a boat that I can paddle at 5 meters per second. The river is moving at 3 meters per second. I want to go straight across the river. What angle do I have to point the boat so that it can go straight across the river? And how long will it take me to get across the river if the river is 50 meters across? Again, it's giving you a few seconds, but I mean, we're going to have the boat, and we're going to have the water, and then there's going to be a result. I'm going to do all the same things I said before, but I'm going to be thoughtful. For example, I'm going to apply a coordinate system here. I'm going to make this the positive x direction, and I'm going to make this the positive y direction. Put an X and Y on my chart. The boat is in the water is in the positive Y direction, correct? It has no velocity in the x direction. So I think the water is pretty easy to deal with. I'm going to put 0 for the x direction and 3 for the y direction. Everybody okay with that? But I understand you don't know what to do with the 5. But you did say that you knew the boat was probably going to have to point this way, right? That's the direction I would have to paddle the boat for it to kind of make it across the river and go in a straight line along where that red line is. I know that this is 5. I just don't know what the angle is. I know you're still confused. Tell me something about the result, though. Do you know something about the result? Aw. Yes?
You're just going to be going straight across.
I do want to go just straight across. That's exactly right, which means the boat will have no y velocity. I know that. Now, that suggests something, right? If the river has a positive y velocity, but the result has to have 0 y velocity, that must mean the boat's y velocity has to be -3, wouldn't it? That's this arrow, isn't it? The opposite side. That would have to be -3. Do you see a pathway? I hope so. Try. See what you can do.